This is chapter 4.5, absolute value inequalities. You're going to see some similarities between absolute value equations and inequalities, but there are a few differences particularly related to the graphing. When you have less than or equal to, it's going to be an and compound inequality. You think about absolute value equations and you remember that inside the absolute value you can either have 10 or negative 10. It usually works out better to have the negative 10 first for your graphing, so we're going to write negative 10 here first, which means x plus 4 and negative 10. Now, we did have an equal sign, but if you'll remember, when we multiply or divide by an inequality by a negative, so again, multiply or divide an inequality by a negative, the sign reverses or flips. So now this is going to be greater than or equal to from less than or equal to. Now we go to positive 10. So we can have 10 inside of the absolute value, so get 10. And so it's going to be x plus 4 is less than or equal to 10. So that inequality symbol remains the same. Now it's simply like solving an equation. You subtract 4 from both sides. X is greater than or equal to negative 14. And then you go over to here, you subtract 4 from both sides, and x is going to be less than or equal to 6. Now, we're going to go ahead and graph it first. Some people prefer to write the compound inequality first, but I'm going to go ahead and graph it first. What you're going to see is that an and compound inequality, that's something that's less than or equal to, is going to be and compound inequality, gives you a line segment. So we're going to draw our number line here. I've got negative 14 and 6, so I'm going to go by intervals of 3. So we're going to go 0, 3, 6, 9, negative 3, negative 6, negative 9, negative 12. Go just a little bit further. Negative 15. Let me fix this. Because it's greater than or equal to or less than or equal to, that's going to be a closed point. So we'll put a closed point here. We're going to have to say it's negative 14 because we're between negative 12 and negative 15. And then 6 we don't have to say because it's right at 6. Now, we know that and compound inequalities are a line segment. But we want to make sure that this is in fact true. So we'll choose 0 because 0 is nice and easy to work with. So we plug in 0 because 0 is part of the solution set. Everything underneath that segment is part of the solution set. So we plug in 0 for x. 0 is greater than or equal to negative 14, so it's a solution. And we come over here, we plug in the 0 now to this x mentally. 0 is also less than or equal to 6, so this is in fact a correct graph of the solution. So all of the numbers from 6 and including 6 to negative 14 and including negative 14 are all solutions. Everything underneath that line segment. Now, I think the graph helps us write the compound inequality first. It looks like it's written properly here, but it's really not. What happens is on an and compound inequality, the x gets sandwiched in the middle. You got less than or equal to, less than or equal to. Now, the 6 is easy because x is less than or equal to 6. So we put the 6 here. Then you stick the negative 14 here. And all that's happened is it's x is greater than negative 14. There's your x is greater than negative 14. You just reversed it around. This is the proper compound inequality. Negative 14 is less than or equal to x. It's less than or equal to 6. Now I'd like you to try numbers 2 and 3. So the absolute value of x minus 3 is less than or equal to 5. And then number 3, which is the absolute value of x minus 8, is less than 1. As soon as you, go ahead and pause it now. As soon as you finish, turn it back on and check to see how you did. Okay, so for number 2, inside the absolute value symbols, you could have a negative 5, the absolute value of that would be 5, and a positive 5, the absolute value of that would be 5. I prefer to put the negative on the left side. It works out better for the graphing. So the only thing that's different here is that, as opposed to the equations, is that when you make this a -5 from a +5, you have to reverse the inequality symbol. So it goes from less than or equal to greater than or equal to. So we ended up with x is greater than or equal to -2 and x is less than or equal to 8. Closed points above -2 and 8. I chose to go by 2s. I could have chosen 4s. That would have been fine as well. When it is an less than or equal to or less than, it's an and compound inequality. And so you're going to have the variable x sandwiched in the middle. And you've got your -2. I like doing the graph first because I can see it. My -2's here, and my 8's here. And so -2 is less than or equal to x. There it is right there. -2 is less than or equal to x. And then x is less than or equal to 8. You can see it right there. X is less than or equal to 8. You should always check. Let's go ahead and use 2 this time because that's underneath this line segment. So we put the 2 in here. 2 is in fact greater than or equal to -2, so it works for the first inequality. And then this inequality, 2 is less than or equal to 8. That is also true. So this is a correct graph of this. Now we go to x minus 8. Absolute value of x minus 8 is less than 1. And again, it's a less than, so it's an and compound inequality. Both of these are and compound inequalities. This one is an and as well. And the difference between equations and inequalities is right here. You've got a -1 that can be inside of there because the absolute value of -1 is 1. And then a +1. But when you change this to a -1, the less than symbol has to reverse or flip and become a greater than. So it's x minus 8 is greater than -8. When you solve it, you get x is greater than 7. For +1, you have x minus 8 is less than 1. When you solve it, you get x is greater than 9. Now look at the graph. You don't have to start at 0, but I always like to go 1 to either side of where I'm plotting. So I went 6, 7, 8, 9, 10. Open points because it's less than. Open points above 7 and 9. It's and, so it's going to be a line segment connecting the two. Let's check out 8 because 8 should be a solution. So 8 substituting in for x is greater than 7, that's true. 8 substituted in here for the x is 8 is less than 9, that's also true. So 8, the line segment is correct. Now here again is why I like to do the graph first. You've got x sandwiched in the middle, you've got 7 on the left, 9 on the right, and you can see right here x is less than 9, there's your x is less than 9. And this is x is greater than 7, but if you flipped it around, that would mean 7 is less than x, so that is also correct. Okay, this is number 1 from page 199. The absolute value of x plus 1 is less than or equal to 4. Again, it's less than or equal to, so it's an and compound inequality. So we're going to go x plus 1. Now, to get the -4, I have to reverse the inequality sign to greater than or equal to. And let's just subtract 1 from both sides. We've got x, this is nothing, it's greater than or equal to -5. Okay, now we go to +4. X plus 1 is less than or equal to 4. Subtract 1 from both sides. X is less than or equal to 3. Now for and, the variable is going to be sandwiched in between. It's less than or equal to. We know that we're going to go ahead and graph it. We've got a 3. It's going to be a closed point. We've got a -5, it's going to be in between, so I'm going to have to say it's -5. It's going to be a line segment. So the way the graph looks, it should be -5. You can see it right there, it's less than or equal to x, it's less than or equal to 3. That's the compound inequality for an and compound inequality. So and means segment, but let's always check it. So 0 should be a solution. So 0 is greater than or equal to -5, that's true. 0 substitute in here, 0 is less than or equal to 3, that's also true, so the segment is correct. Alright, now let's go ahead and do another one here. This is going to be an or compound inequality because you can see it's greater than or equal to. Greater than or greater than or equal to is an or compound inequality. And those will be two rays going in opposite directions. So we've got negative 3 inside is a possibility, or positive 3 inside of the absolute values. So it's 1/2 x minus 1, and you're going to have to reverse the inequality sign to less than or equal to -3. You change the sign, so you have to reverse the inequality symbol. You add 1 to both sides, so you end up with 1/2 x less than or equal to -2. Now, here's where sometimes kids get a little stuck. To get rid of a fraction, you multiply by the reciprocal of 1/2, which is 2 over 1, or just 2. Do that to both sides. And so 2 times 1/2 x is just x is less than or equal to -4. Then we go over to positive 3. So we have 1/2 x minus 1 is greater than or equal to 3. We add 1. 1/2 x greater than or equal to 4. Again, to get rid of a fraction, you don't divide by a half, you multiply by the reciprocal. The reciprocal of 1 over 2 is 2 over 1, or just 2, which gives you 1x, or x. Multiply the other side by 2, which is 8, so greater than or equal to 8. Now, we know that when it's an or, greater than or equal to, or just greater than, or a compound inequality, it's two rays in opposite directions. So it's a closed point over -4, a ray going to the left. It's a closed point over 8, a ray going to the right. You can see I chose to go by 4s. So I have 0, 4, 8, 12. I go just beyond the 8, and then 0, -4, -8. I just go one interval beyond the -4. We should again check it. So we use 12. 12 is greater than or equal to 8. That's true, so this one's okay. We use -8. -8 is less than or equal to -4. That's true. So it's rays in opposite directions. Now these are written almost exactly like you're seeing them here. It's just going to be x is less than or equal to -4, or x is greater than or equal to 8. The only thing that differs from here to here is the word or. And let me fix this little spot right here. X is less than or equal to. So there's your compound inequality. There's your graph. Okay, now you're going to get to try one of these. This is an or compound inequality, except for being greater than or equal to, it's just greater than, which means it's going to be an open point. So you could have -7 inside the absolute value symbols and still get 7, and +7 inside the absolute value symbols and still get 7. Go ahead and pause the recording, try it, and then check your answer. Okay, so inside of these absolute value symbols, x can be a value that will give you 7 or a value that gives you -7. So for -7, you have to reverse the inequality from greater than to less than. So it's 2x plus 3 is less than -7. Subtract 3 from both sides. You end up with 2x is less than -10. Divide both sides by 2, x is less than -5. For the positive side, 2x plus 3 is greater than 7. Subtract 3 from both sides. 2x is greater than 4. Divide both sides by 2. You get x is greater than 2. Okay, it is an or compound inequality because it's greater than. And when it's or, it's going to be rays in opposite directions. These are open points because it's just greater than. So we have open point over -5 labeled. Open point over 2, it doesn't need to be labeled. Rays in opposite directions. Let's check it. So here's -6. -6 is less than -5, so that's true. Here's 2. X is greater than 2. We'll choose 4 to put in for the x because it's underneath the ray, so 4 is greater than 2. That's also true. That's the end of this recording. Hopefully it's been helpful. Go back and watch any parts you are having trouble with.